What's up guys, and welcome back to another wonderful video of physics. Today we'll be discussing the very exciting topic of two-dimensional motion. However, you may remember that in the previous video we talked about one-dimensional motion. You may wonder, well, what's the difference? The difference between one-dimensional motion and two-dimensional motion is that while one-dimensional motion is motion in a single x-axis, 2D motion is motion in, you guessed it, both an x and y axis. While this doesn't seem so complicated, it will require the inclusion of a subject in mathematics that all fear. Trigonometry. All jokes aside, trigonometry is actually a pretty simple concept to understand and use. In essence, trigonometry is used for solving different parts of a triangle. However, it can be only used on right triangles, triangles that have one 90-degree angle. There are three trigonometric functions: sine, cosine, and tangent. The sine of an angle is equal to the opposite side of the angle divided by the longest side, or the hypotenuse. The cosine of an angle is equal to the adjacent side of the hypotenuse. And the tangent of an angle is equal to the opposite side divided by the adjacent side. A good way to memorize this is SOHCAHTOA. Now let's try out a different problem. Let's start off with this right triangle right here. Let's say this angle is 30 degrees. Then let's say that the longest side, the hypotenuse, is 8 meters long. From here we can solve all the sides of the triangle. How would you be able to do that? Well, if we were to solve for this side, then we would have to use sine, because the sides included are the opposite side of the angle and the hypotenuse. Let us use our mnemonic, SOHCAHTOA. So, sine of the angle is equal to the opposite side of the angle divided by the hypotenuse. If you want to, you can pause the video here and plug in the stuff into the equation and calculate it yourself. So, when you do plug everything in, you can solve for x, which should be 4 meters. Let's try to solve for the other side. Now, which trigonometric function should we use this time? Pause the video here and try to figure it out. And you're absolutely right. We should use the function of cosine to solve for the last side. And why is that? Because SOHCAH and the sides included in the problem are the adjacent side and the hypotenuse. Now that you know which function to use, plug in all the components into the equation and solve for y. Now once you solve for y, the answer should be 6.928 or 4/3 meters. If you want to find out how to use the tangent function, go to khanacademy.org and find out more about trigonometry. But I think now you get the general idea of how trigonometry works, so let's jump into motion, no pun intended. Now let's talk about a few equations that will be essential to everything you do that's motion related. These equations are known as the equations of kinematics. You use each of them in a specific situation when you are missing certain parts to an equation, but you have everything else. For example, this equation can be used when you are unaware of the time passed in a certain time frame, or this equation can be used when you don't know the acceleration of an object. Basically, all these equations have a unique use. Now, let's apply what we learned to an actual problem. What we're about to solve is a problem in the category of projectile motion. In projectile motion, movement is split up into two different directions, the x-axis and the y-axis. Now prepare to be really confused for a few moments. On Earth, there is a perpetual downward acceleration of 9.8 meters per second squared called gravity. This means that with projectile motion problems on Earth, there will always be a downward acceleration in the y-axis. Now with that knowledge, let's solve this problem right here together. The ball is launched from this cannon at 40 meters per second at a 30-degree angle. With this information, how far away does the ball land? Since this is your first time, I'll walk you through the steps. So the first thing you want to do in a complex problem like this is to say what kind of information you were given in the problem. So you're allowed to assume that you're on Earth because cannons don't exist in space, and so you can write down that the y acceleration is negative 9.8 meters per second squared. For the sake of your mental health and sanity, you are allowed to neglect air resistance in this problem, meaning that there is no x acceleration. And you know because I told you that the initial velocity is 40 meters per second at 30 degrees. Now that you have all your given information gathered, you can start to evaluate the problem. You don't yet know the separate x and y values for initial velocity though. And how else to solve for those than using our newly required knowledge of trigonometry? If you look close, you can see that the trajectory of the ball can be split up into an x and y direction. Let's solve for the initial velocity in the x direction first. What are the sides involved? The adjacent side and the hypotenuse. SOHCAH, so we must use cosine. Once we plugged everything in, we should get 3.4641 or 20√3 meters per second. So now we know the x value of the initial velocity of the ball. Because we also know that there is no acceleration on the x-axis, we can officially declare that the final velocity in the x-axis of the ball will be the same. Now let's analyze the y-axis components to the problem. First, let's find the y-axis part of the initial velocity. So sine, opposite over hypotenuse, blah blah blah, and so you end up with this equation. Once you solve it, you get 20 meters per second. Now if we imagine this ball going upwards and falling back down, the velocity at which it takes off the ground will be exact same in the opposite direction when it hits the ground. What exactly do we need here to get somewhere in the problem? Well, I know, we can use the legendary equations of kinematics, but which one? I know, how about this one right here? We don't know how long the ball will be in the air, and in this equation, what is missing is the y displacement of the ball during the problem, which is another thing we don't know, but we don't need. You may ask, what do you mean? We don't know the final velocity of the ball in the y direction, but we do know that the ground level will not change. So the instance before the ball hitting the ground is when the velocity of the ball will be the exact opposite of the initial velocity. So yeah, let's plug in everything we got into the equation. Once you got everything in and you solve it, you should get 4.8, or to make things easier, approximately 4 seconds of flight time. Okay, so now that we know the amount of time the ball took while flying through the air until it fell a certain distance, let's solve for what we set out to achieve in the first place, the distance that the ball covers. For this, let's go back to the x-axis part of the problem. Now that we know the flight time, we can use velocity is equal to distance over time to solve for the distance covered. So, we plug everything in and we got our answer. The answer is 138.56, or 80√3 meters per second of displacement. Woo, we got the answer. After writing all this, though, I realized that the problem was actually really complicated among 2D motion problems. Mostly because the projectile starts off at an angle, but if you understood all of it, you're an absolute genius. Again, if you didn't quite get what this problem is all about, rewatch, comment, or go to Khan Academy to have it explained to you, probably better than I can. 2D motion requires a lot of hard thinking, so it may take a while to stick in your brain. But once you get it, it stays forever and haunts you for the rest of your life. But anyway, if you learned/enjoyed something from this video, then it was a success. Bye bye, and see you all later in the next video.